this video, we're going to look at an application of the Pythagorean theorem. So before we get started, let's refresh our memory about what the Pythagorean theorem is. And the Pythagorean theorem says that when we have a right triangle, and if we label the legs A and B, where the legs are the sides touching the right angle, and we label the hypotenuse C, where C is the side opposite the right angle, also the longest side, and we know the relationship between the lengths of the sides will always be a squared plus b squared equals c squared. So in this application, we're assuming knowledge of this theorem. So let's read the problem. The hypotenuse of a right triangle is 5 meters more than the longer leg, and the shorter leg is 15 meters long. Find the length of the longer leg. So when we read an application problem, we often read it several times, and each time we're getting different information from it. The first time we read through it, we're looking for the general context. For example, in this case, they mention a right triangle. They also are mentioning the lengths of legs. In fact, we're looking for the length of the longer leg of a right triangle. This is our big clue that we're going to be using the Pythagorean theorem. As soon as you notice that you have a shape mentioned in your application problem, you're going to draw a picture of that shape. It doesn't have to be to scale, but just to give you an idea of what's happening. So as soon as I read right triangle, I draw my right triangle. Then I go back through the problem and try to figure out what are my knowns and my unknowns. Often, we know what to label as x, our unknown, by looking at what we're being asked to find. In this case, we're asked to find the length of the longer leg. It's not always the best choice for x, but it often is. So let's consider calling the length of the longer leg x. So one of the two legs, the sides adjacent to the right angle, should be labeled x. You'll notice in my diagram, it's not clear which side is longer, and that's not really that important, as long as one of the sides is labeled x. Now let's see what other information we have in the problem. It says the hypotenuse of a right triangle is 5 meters more than the longer leg, and the shorter leg is 15 meters long. Find the length of the longer leg. So another piece of information you might notice that's fairly straightforward is that the shorter leg is 15 meters long. So I'm going to go ahead and label the shorter leg as 15 meters. So right now we have two of the sides labeled. We would like to label the other side, in this case the hypotenuse, using the same variable or an expression written in terms of that variable x. Let's look at how the hypotenuse is described. The hypotenuse is described as being 5 meters more than the longer leg. So since we labeled the longer leg x, this is going to work out really well because we can just say that the hypotenuse is x plus 5. Okay, now that we have some kind of an expression to represent each side of the right triangle, we can go ahead and make a relationship between these using the Pythagorean theorem. So we just need to identify A, B, and C. It doesn't really matter which is A and which is B. I'm going to say A is x and B is 15. But definitely C has to be the hypotenuse, which in this case is x plus 5. So we know that x squared plus 15 squared is equal to x plus 5 squared. And we have an equation we can solve for x. Now, before we can really decide what kind of an equation this is it a quadratic equation? Is it a linear equation? We really need to multiply out the x plus 5 squared. It wouldn't hurt to simplify the 15 squared either. Let's see, 15 times 15 is going to be, carry the 2, 75 plus 150. So we get 225. So we have x squared plus 225 equals. Now a common error here is to think that we can just square each part of this expression and write x squared plus 25. But that would be incorrect because this expression actually means x plus 5 times itself. And you notice if we multiply every term in the first factor times every term in the second factor, we are actually going to get more than just those two terms. You might know this as foiling: first times first, outer times outer, inner times inner, and last times last. X times x would give us x squared, x times 5 would give us 5x, 5 times x would also give us 5x, and 5 times 5 would give us 25. Here we can combine like terms on the right to get 10x plus 25. And I'm going to go ahead and subtract x squared from both sides. So now we see what kind of equation we really have. 225 equals 10x plus 25. This is just a regular old linear equation. In other words, there's no power on the x, it's a power of 1. So we can just isolate x and we have our solution. So how do we do that? We're going to subtract 25 from both sides of the equation. And that would leave us with, coming over to the left, that would leave us with 10x is equal to 200. Dividing by 10 then, x is equal to 20. All right, so let's go ahead and figure out what we just figured out. What you always need to do is make sure you're actually answering the question. So what we just found is that x is 20 meters, and x plus 5 then, the hypotenuse, if we put 20 in for x, is going to give us a hypotenuse of 25 meters. But what were we asked to find? The longer leg. That was x. So the solution to this exercise is 20 meters.